if and only if
It's a single number.
it is a single, just clear, just to specify, number. Not infinity, negative infinity, or I don't know for sure. If it's I don't know for sure, most probably there is no limit. Again, what are the options for the preliminary assessment when I determine the limit of a function and when x approaches a and I get not zero? So we're going to start with this now to discuss this situation. But I have not 0 over 0, but whatever over 0. What are the three possibilities? But only one. But these are all possible options. But what is the only answer that could get? Could I get here?
Negative infinity, infinity, and does not exist.
That's it. Excellent. Good. So before I start today, I would like to answer any questions you may have, anything that you encountered, anything you need help with. Any questions?
Professor, I have a question.
Yes, I'm ready.
So I don't know if you probably already mentioned this, but I had a question in regards when there is a negative sign, like, because that kind of confused me when doing the homework.
I'm not sure about negative sign. Can you give me an example so we can we answer the question at hand? I'm not sure. Yes, I'm ready.
X, so X, and then the arrow -2 with the,
You're talking about this or you are talking about this?
Yes. It had both, like the -2 and then the dash on top as well.
Good. Of what?
Of f of x.
But you have to give me f of x. I can't answer without the f of x. What is f of x?
That's what the homework said. Like there was a graph.
But you have a graph. I have to see the graph.
Yeah.
You can share your screen, or you can tell me which problem this is, and I have to go to the graph.
Okay, that's fine. So if you want, do you want me to do it right now or later?
Just tell me which page number or which graph, which problem, just anything, so I can.
Yes.
Okay.
Okay, just give me one question. I had it right here. Give one moment. I'm sorry.
Sure.
It's page 113 of the book. Problem 32.
Good. So I have the book opened. I just need to go back and share my screen. And you said 113. Oh, is this 113? No, 113.
I think it was the homework problem.
That was due today?
It was the homework.
That was due today?
Yes.
Okay, very good. So in 32. So you're talking about this?
Yes.
So the limit of f of x as x approaches -2 from the left. Okay. Very good. This is the function. This is problem 32. The limit of f of x as x approaches -2. Here is -2. Here is from the left. And now I follow the function. Which number is the function approaching? I'm not asking what is the function value. I'm asking which function value, which number is the function approaching?
So would it be 5?
But 5 is here. and the function goes here.
Okay, yes, I see what you mean now. So it would be 4, right?
Exactly.
Okay. Thank you.
Thank you. I'm kindly asking and begging my students always, if they find the time to review and watch the videos, you will be able, I guarantee, you will be able to teach this class next semester. I guarantee you.
Can I ask a question?
Say it again.
Can I ask a question?
Absolutely, any.
So I'll share my screen to make it
Yes,
easier.
yes.
So for 1.2,
Yes.
we
We haven't finished 1.2, but I'm glad you started.
I already finished it.
That's great, but I haven't
Okay.
shown much other than how to find the limit of a polynomial, a rational, and a radical. So I haven't gotten to others, but please do tell me what it is. So
Okay, the
yeah.
homework wasn't that hard, so that's why that's what I meant to ask you is, did we do the stuff yet? Because it wasn't
No,
that hard.
no.
Okay,
It may not be hard, but I didn't get the chance to finish.
okay. Well, it was. Sorry, it actually wasn't 1.2 then. It was. Sorry,
No
think it was-
worries.
1.1 maybe.
Okay.
Let me check real quick.
Yes, 1.1 we finished. 1.1 we finished.
Okay, it must have been that.
Sure.
It was like it's when they give you two functions and like it's like x is greater than or equal. Yeah, this one right here.
Yes. So this is what we did last. This is
really
what we
long
did last time. The last problem. This was this.
Okay. So this took me a really long time to figure out because one, I forgot what you taught us, and then the example, like, it was just a lot and overwhelming.
That's why I'm
So,
saying that if you watch the videos, you will be able to teach this class next time.
yeah. So if I just plug in, if I make these equal to each other and then solve for c by plugging in 5 for c, that's how I got 4. Is that like the right way to do it?
So, because it's asking us, I can see what it's asking. Can you read what it's asking?
Determine the value for c so that
The limit exists. Okay. Yes. So if you want to stop sharing for a second, very good point. So here, the limit does not exist, right? Because the limit from the left is 1 and the limit from the right is 0. So the limit at 3, the limit as x approaches 3 from either side does not exist. From the left exists, is 1. From the right exists, it's 0. But from either side, it does not because they are not equal. Now, your problem, and I would like you to read it because I want to work on it right now. It's a very good point. So your problem, if you'd like to give me the function. So what was it? F of x equals
f of x equals 1 over 5x plus c, for x is less than 5, and the second is negative x plus 10 for x is greater than 5, not equal to.
Okay. Good. So in order for the limit to exist, as we look at this function, we know that f is undefined at 5 because there is no equal symbol here and there is no equal symbol here. So obviously f is undefined at 5. So if it's undefined at 5, for the limit to exist, I don't even look at it, we analyze the idea. So for the limit at 5 to exist, the limit from the left and the limit from the right must be the same. We don't care whether the function is defined at that point or not. The limit does not mean what is the function value at 5. The limit only says, where is this branch going? Where is this branch going? If they go to the same number, then the limit exists from either side. If they go to separate values, then the limit will not exist. So then, for the limit to exist, I have to write that the limit as x approaches 5 from the left with numbers smaller than 5 from 1/5 x plus c must equal, and of course I always run out of room, so I'm going to do this, or not, or just write it from the beginning here, so there is no confusion. So the limit as x approaches 5 from the left from 1/5 x plus c must equal the limit as x approaches 5 from the right from negative x plus 10. Only in this situation, the limit as x approaches 5 from either side exists.
Okay, that's super important right there what you just wrote. That like makes me completely understand it.
Yes, because here there is no way that the limit from either side at 3 to exist, because this is 0 and this is 1. The limit will exist if both sides are the same number, but they're not. But here we have something called a parameter. Actually, I was talking to my other class a few minutes ago, before you came in, about this situation. So then the limit as x approaches 5 from the left, remember, this is a polynomial. I'm thinking, how do I find the limit of a polynomial? Oh, simple. I plug it in. 1/5 times 5 is 1. 1 plus c. This limit is 1 plus c. It must equal, how do I find the limit of a polynomial? Easy. Plug it in. Negative 5 plus 10 is 5. So therefore c equals 4. Only if c equals 4, the limit from either side will exist. If c is any other number, the limit from the left will not equal the limit from the right, and this one will not exist. Very good point.
Got it.
Thank you. Very good point. Thank you. Perfect question. So that's why I'm kindly asking you to do the work so you can ask these questions. So I know, you know, how to proceed. Any questions on this or anything else? If not, I just want to briefly discuss this situation, which is not this situation. So let me see what you see, because it's got quite far. I'm going to pin myself to see better. Okay, good. So we already know that this has something I call no hope. A number divided by 0 has never had and it will never have hope of existing. This could never be a number. So the options here are these. This one has hope. By saying has hope, I'm not saying the limit exists. I'm saying it's not like this one. It may exist. It may exist. There is no guarantee. So this is a good one. This is done. Here, there is nothing we can do about it. Okay, and now I would like to practice a few examples. And from this section, which is, I have my book right here, page 124. We had a few examples, but not enough. So on page 124, I'd like us to look at a few. So see, these are polynomials, right? We know that. Linear, quadratic, quadratic, 4th degree, 5th degree, linear, quadratic, quadratic. Please choose an example that you would like to work on, or I will. 1, 2, 3, I will choose 13. So please be quick. So limit as x approaches 3. If the color I'm using is not good, please let me know. Okay. Of x squared minus 4x plus 7. It's a polynomial. How do I find the limit? And can anyone give us the limit?
You plug in 3
Yes.
for x.
Yes. So 9 minus 12, negative 3, plus 7. Oh, am I sharing? I'm still sharing?
Yes.
Oh my goodness. Sorry. Or I'm not sharing at all.
No. We can see what you're doing.
So sorry.
You're not sharing the screen. That's
I
why we didn't
forgot to
choose
share
that.
the screen. Yes, I'm sorry. I'm
Yeah,
sorry. That's why you couldn't.
That's
You.
why we didn't choose
Yes.
that question.
That's why I didn't hear Jonathan picking something weird for us. No, I'm kidding, Jonathan. Of course. So I'm sorry. I didn't mean to do that. I thought I was sharing the screen. So I picked this one. So x squared minus 4x plus 7. The limit as x approaches 3 from either side. Sorry about that. And now what do we get?
4.
Yes, indeed. 9 minus 12 plus 7 equals 4. Done. So this is a polynomial. No questions there, I assume. Okay, so let's share again. Now I would like to pick a rational. Of course, these are rational functions. These are rational functions.
We do 17.
17, very good. Okay, so limit, again, x approaches 3 from x squared minus 8 over x minus 2. Okay, here we stop.
Still sharing. We can't see it.
I'm sorry? No, I just wanted, yes. So I wanted to ask, first of all, since this is a rational, so this is a polynomial function, this is a rational function. Can anyone remind us how we determine the limit of a rational function? What do we have to check first? Because remember, we have to do the preliminary or the assessment. I need to do the assessment. What is the assessment? Okay, let's see the assessment. Plug in 3 and tell me what you get.
9 minus 8.
1. Perfect. Plug in 3 and tell me what you get.
1.
Perfect. Because 3 is in the domain, 1 over 1 is 1. Done. That's it. If 3 is in the domain, it behaves like a polynomial. It's not a polynomial, but we use the same procedure. Okay. Now let's move on to the next set. The next set says, find the limit. Okay, so these are rational except this one. This is a combination of square root and rational. So these two, but everything else is rational. You choose or I will.
27.
24.
Okay, so let's start with the 27. This is my page 3. Let me start a new video because I got to 8 10 minutes.